Okay, welcome to this next video, 4.6, which is the surface area of a solid. We're only doing regular solids, regular prisms, okay? So rectangular, triangular prisms only. So there's not a lot that you have to worry about, okay? So we've just finished doing the volume of a prism, the space that it takes up, and now we're going to talk about the area on the surfaces of that shape and that object. So consider this little box, a rectangular box, so it's sort of a rectangular prism, unsurprisingly, and pretending this is an actual cardboard box, how would you calculate the amount of cardboard needed to make this box? Okay, so it's sort of a fairly simple question, but how would you do it? How do we know how much cardboard it would take to make this box? So what we could do is, well, okay, let's unpack this. So maybe you've taken apart a cardboard box before, but let's sort of check this out. We've got this side here, okay, so it's sort of a square, okay. Got this one at the top here, which is a bit of a longer one, and then this square is repeated at the back. Then we've got this longer piece on the bottom as well, okay. But so we've gone the 1, 2, 3, the one at the back, and 4, the one at the bottom. We've also got to consider this one here and its corresponding one on that side. So they're kind of like this, okay. So when you're doing surface area, you want to be thinking about this. What does my shape look like when I take it apart? Okay, so you're putting it into a whole series of areas. And once you've done this, I mean, it's simple. You guys know how to do compound shapes. And so what we've done here is we've just created a compound shape of squares and rectangles. And so what you do, as you look down here, is that to calculate the total area of all these, to calculate the surface area of this shape, you would say, let's make this 1 and 2 and 3, 4, 5, 6. So the surface area of this is going to be equal to the sum of the areas. Okay? So when we calculate the total area of all these sides, that's something that's called the surface area. Okay, so that's a technical term I want you to remember. This idea here, the surface area. Okay, it's an actual thing. It's working out all the areas that are around the outside of this prism, or any shape really. So a couple of key ideas for you. First, you analyze the solid to find any duplicate sides, because if we have a look at this one up here, there are a couple of duplicate sides. I mean, this one's the same as this one here. This one here is going to be the same as that, and this one here is going to be the same as that. So you can make your calculations quite easier if you figure out the sort of how you can shorten it down by creating like terms of areas and that kind of thing. It makes it very, very quick, very, very simple. Right, so you analyze the solid to find any duplicate sides. Secondly, you find the area of all these sides that you need to. And finally, you add the areas of all the sides. So if you know how to do area, you know how to do surface area of solids, okay? So a couple of examples so you can see how this works out. I've got a regular rectangular prism here, okay? So we want to think about drawing ourselves what's called a net, okay? So draw a net diagram. Okay, and it's kind of like if we unfolded this thing into all its sides, if we're going to make it out of cardboard. Okay, so I've got this short bit at the top, long piece, short piece, long piece. Okay, so that's unwrapping from here to this one here to around the back, and then the one that's underneath. Okay, then I've got these two pieces as well to worry about, and they're here and here. Now let's look at some of these measurements. This length here is given to me as 10 centimeters. This length here is given to me as 6 centimeters. And these small pieces here are given to me as 2 centimeters. Okay? Right, so let's talk about our duplicate sides. Okay? So, duplicate side A is the same as this one here. Okay? This one here, B, is going to be the same as this one. This one here is C, okay? So we might go for this, okay? The area of piece C is going to be equal to 6 times 2, okay? So 6 times 2 equals 12 centimeters squared. Okay, the area of piece B, which are these ones here, is equal to 2 times 10 centimeters equals 20 centimeters squared. Don't really need the centimeters here. And then finally we have the area of piece A, which is equal to 6 times 10. 6 times 10 equals 60 centimeters squared. Finally, to find the surface area, let me scroll down a bit. So now, to find the surface area, different color, surface area is equal to 2 pieces of area A plus 2 pieces of area B plus 2 pieces of area C. So we've got 2 times 12 let's just fix that up. So we got 2 times 12 here, plus 2 times 20, plus 2 times 60 is equal to 24, plus 40, plus 120, which is equal to 184 centimeters squared. Okay? So all we've done here is we've broken it down into a series of easily doable steps by themselves, and then end up with this one here for the surface area of this shape. Okay, so let's scroll down and have a look at our next one. So kind of draw off here. Hopefully I've got plenty of room this time. So we've got a triangular prism here. First thing you want to do is draw a net. Now this is going to be different. You kind of don't unwrap it across the top and underneath like we did with our rectangular prisms. Instead, sort of think about, let's get this bottom piece here, okay, that's underneath the bottom there, and we sort of make that our first piece we're going to start off with. Okay, now so if we cut along the top here and fold those two pieces out, we're going to get a rectangle here and a rectangle here, and we're going to have a triangle here and a triangle here. Okay, so if you can see, those triangle pieces are these ones here, and we've got our 3 sides of our triangular prism. Okay, so now you're going to have a look at your drawing and try and put some of the dimensions down. So we've been given a height here of 3 centimeters, a base length here of 8 centimeters. This big length here is 10, and these ones here are 5. Okay. So you need to make sure that you are, that's probably the hardest part, is drawing this net and working out how these dimensions on the 3D drawing relate to this 2D layout. Okay, so we want to try and see if we got any equivalent pieces. So you should be able to see straight away that this piece A is the same as this piece A. So that's the pieces that make up this side and that side there on the back. Okay, they're going to be exactly the same because we've got 5 times 10, 5 times 10. Okay, so the area of piece A is going to be equal to length times width, which is equal to 5 times 10, 50 centimeters squared. Okay, next we will move on to this piece here. This is just piece B. It doesn't have a duplicate in this one. So the area of piece B is equal to 10, which is this length here, times 8, which is this length here. So length times width is equal to 10 times 8, which is equal to 80 centimeters squared. Okay, and finally, we have the triangle pieces. So C and C, you can see that they're going to be exactly the same size. So the area of PC is going to be equal to half base times the height, which is equal to half of 3 times 8, which is 12 centimeters squared. Okay. Finally, to find the surface area of this shape is equal to 2 of area A plus only 1 of area B plus 2 of area C. Okay, so again, important to realize that there's not 2 of these area B's, there's just the 1. So that's going to be equal to 2 lots of 50, so 100, 1 lot of 80 plus 80 plus 2 lots of this one is 24. So it looks like we've got 204 centimeters squared. Okay, so as you can see with surface area, as long as you can do areas, normal things like rectangles and triangles, and actually that's it as far as you guys are concerned, then you'll be able to do surface area. The hardest part is this step here, going from the 3D shape here to the 2D layout, 2D net, and then working out how many of each piece of area you need to add together to get the total. Okay, so thanks for watching. Make sure you have a look at those. Make sure you do enough to get comfortable with it. Really, it's a very easy area of our geometry this term. Okay, thanks for watching.